Hi everybody, and in this video I want to just talk about another kind of application of exponents and logarithms, which is the Richter scale. Now the Richter scale is a way of measuring the intensity of an earthquake, and the more the intense an earthquake is, the more vibration it causes on a kind of a scale type of apparatus that is used to measure movement in the earth. And I guess they call that scale the Richter scale. But if you look at the chart here, what you see is if an intensity of an earthquake is fairly low, then what you could say is that it produces vibrations on the magnitude of 10 to the power of 1, right? We don't know what that means. That could be like the size of the ripples, or it could be just the frequency of them, but it doesn't really matter. But all we're trying to look at is say to ourselves, we're trying to get a method of comparing how intense earthquakes can be. And I think what has been determined is that there is a huge variation in the intensity of earthquakes. And so like if you're thinking of it in terms of just like a line chart, where ripples on the line represent earthquakes, you could see little ripples like this, and then smooth would be no earthquakes. But then you could suddenly see ripples like this, and the difference between the microscopic little variations compared to the very big ripples would be actually quite intense in terms of how much damage the earthquake could actually inflict. So what we find is an earthquake that produces huge variations on the Richter scale will be many thousands of times as intense as an earthquake that basically makes no ripples whatsoever. So because of that huge difference in terms of the damaging power of the earthquakes, what we need is to understand that a scale that somehow captures this under normal circumstances might not be possible. So we need to try and, simplify a scale down to numbers that are more workable. And that's where the Richter scale comes in. So if you look at the chart, you see that we have this column that says true intensity. And in the second column, it says 10 to the power of 4. Well, 10 to the power of 4 is equal to 10,000. Whereas 10 to the power of 1 is equal to 10. So an earthquake that produces a true intensity of 10 to the power of 4 means that it has an intensity on the scale of 10,000, whereas the Richter scale measurement that has a true intensity of 10 only has an intensity of 10. So that's 1,000 times more powerful between those two. So what we do is we can just basically, instead of saying that the second number is 1,000 times more powerful, we can just use logarithms to break those numbers down into just simple reference numbers and say that an earthquake that produces an intensity of 10 to the power of 1 would just be a 1 on the Richter scale, whereas an earthquake that produces an intensity of 10 to the power of 4 would be a 4 on the Richter scale, and so on. And whereas an earthquake that produces an intensity of 10 to the power of 5.8, which is a huge number, well, that would be a 5.8 on the Richter scale. So with that in mind, what you see is usually when an earthquake occurs in a place, the news report will tell you what the earthquake was on the Richter scale. And when you get that information, it is possible to compare the earthquake's intensity to other earthquakes. And what you'll find is that it's actually quite a huge disparity between different things. So what we'll do is we'll take an example here and we'll look at it. It says an earthquake of magnitude 2 is actually 10 times more intense than an earthquake of magnitude 1. The difference between the magnitudes of the two earthquakes can be used to determine the difference of intensity. So here we say if the average earthquake measures 4.5 on the Richter scale, how much more intense is an earthquake that measures 8? Now, earthquakes that measure 8 on the Richter scale are quite rare, but all you're really doing is you're comparing the intensity of the two earthquakes. So what you're doing is you're saying, what is a 10 to the 8th intensity earthquake over a 10 to the 4.5 intensity earthquake? you're just taking a ratio, as it were, between the two earthquakes. And what you're saying is, well, that's really equal to 10 to the power of 8 minus 4.5, which is equal to 10 to the power of 3.5. And then you can simply say, you can take out your calculator and you can say, well, what is 10 to the power of 3.5? And 10 to the power of 3.5, that's equal to 3,162. So 3,162, and we'll just say 0.28, or we'll say 0.3 just to round off, okay? So what that means for us is it means that the earthquake that is 8 on the Richter scale is 3,162 times as intense as your average earthquake. Now, what does that mean for the average person who's standing around in the middle of this Richter scale 8 earthquake? Well, it means that the intensity of the vibrations that that person is feeling is 3,000 times more than the intensity of the vibrations that somebody would feel if they were just standing in a normal earthquake. So how can we put that into perspective? Well, I don't know. I mean, think about if a pitcher threw a baseball at you at a speed of 80 miles an hour, right? So, and that's very fast. If any of you ever had any kind of thing thrown at you at 80 miles an hour, you're going to realize that that's extremely quick. Well, if I take that same baseball speed, 80, and times it by 3,000, just for rounding sake, that means that the baseball pitcher would be throwing the ball to me at about 240,000 miles an hour, which would mean that I would probably swing and miss. But it would also mean that the catcher and the umpire would probably explode when they tried to catch it. So it wouldn't be a very pleasant experience for the people involved in the experiment. All I'm trying to say to you is that basically, that's a huge difference. An earthquake that is 3,000 times as intense as an average earthquake. And trust me, if you lived in Canada, just an average earthquake would feel quite unnerving, as it were. But in other words, it would be very, very intense. So that just gives you an idea of the difference between the intensities of two earthquakes. And as you can see, like the logarithm part of it doesn't really come too much into play. The only purpose of the logarithm portion of the situation is just to take the intensities and I call it pare it down, or kind of reduce it down to a single number, right? So that 10 to the power of 5.8, if you take the log of that, the log of 10 to the power of 5.8, right, is equal to essentially some number. Well, what you're saying is, what would I have to raise 10 by to get 10 to the power of 5.8? Well, I'd have to raise it to 5.8. And so that's your Richter scale measurement, right? Anyway, that is what we are looking at for Richter scale. And I think that the main application, as I said, is essentially just comparing the intensities of different earthquakes. So I hope they found that helpful, and I would think that it's a good idea to try some of the questions in the textbook, which I will assign.